Hello everyone, my name is Prashant from BSc Chemistry Honors first year, and today we are going to study chemical kinetics. So here the chemical kinetics is a branch of physical chemistry which deals with the study of the rate of reaction, the factors which govern these rates, and the mechanism by which the reaction proceeds is called chemical kinetics. Three categories of various reactions. The reactions which take place almost instantaneously, for example, ionic reactions. AgNO3 plus NaCl gives AgCl plus NaNO3. Second one is those reactions which take place extremely slowly. For example, rusting of iron, combustion of H and O2. And the third one is those reactions which take place at measurable speeds. For example, CH3COO C2H5 plus H2 in presence of H positive gives CH3COOH plus C2H5OH. Rate of reaction. The rate of reaction may be defined as the speed or the velocity with which the reaction takes place. Or the rate of reaction may be defined as the change in the concentration of any one of the reactants or products per unit time. For example, PCl5 gives PCl3 plus Cl2. Rate of this reaction. Decrease in concentration of PCl5 upon time taken. Units mole per liter per second or mole liter inverse minute inverse. Law of mass action. The rate of reaction at any time, called instantaneous rate, is defined as the change in the concentration of any one of the reactants or products per unit time at that particular instant of time. Rate of reaction dx by dt. For example, consider the reaction A plus B gives P plus Q. Rate of reaction dx by dt is equal to negative dA concentration of A by dt is equal to minus D concentration of B by dt is equal to plus D concentration of product by dt is equal to plus D Q by dt, where D concentration of A and dB represent small decrease in the concentration of A and B respectively. dP and dQ represent small increase in the concentration of P and Q respectively in the small interval of time dt. For a more general reaction of type A plus BB gives PP plus QQ. Rate of reaction is always positive. Negative sign shows decrease in the concentration of reactant. Positive sign shows increase in the concentration of product. Factors affecting rate of chemical reaction. Effect of concentration. We know from law of mass action that rate is proportional to concentration of reactants, so rate of reaction decreases with passage of time. Effect of dielectric constant of medium. More is the dielectric constant of medium, greater will be the rate of ionic reactions. Here we can see the graph, and here effect of temperature. In the early days, the effect of temperature on reaction rate was expressed in terms of temperature coefficient, which was defined as the ratio of rate of reactant at two different temperature differing by 10 degrees Celsius. Tc is equal to Kt plus 10 by Kt is equal to 2 to 3. In general, K2 by K1 is equal to Tc raised to power delta T by 10. Note that for some reaction, temperature coefficient is also found to be less than unity. For example, 2NO plus O2 gives 2NO2. Rate of reaction decreases on temperature increasing. Method of temperature coefficient wasn't exact. It is just a generalized way to analyze the effect of temperature on the rate of reaction. Effect of nature of reactants and products. Physical state of reactants. Decreasing order of rate of reaction because collisions in homogeneous system are more effective than heterogeneous system. Physical size of reactants. As we decrease the particle size, rate of reaction increases since surface area increases. Chemical nature of reactants. If more bonds are to be broken, the rate of reaction will be slow. Similarly, bond strength is more, rate of reaction will be slow. Effect of radiations. Light. Radiations are useful for photochemical reaction. Effect of temperature. Pressure is important factor for a gaseous reaction. Effect of catalyst. Presence of positive catalyst lower down the activation energy, hence increase the rate of reaction. Presence of negative catalyst increase activation energy, hence decreases the rate of reaction. Effect of pH of solution. For example, FeCN6 or negative gives FeCN6 whole 3 negative. The reaction takes place with appreciable temperature rate in the acidic medium but doesn't take place in basic medium. Order of reaction: total sum of power raised to the molar concentration the reactants according to rate law is called order of reaction. And N2 plus 3H2 gives 2NH3. Rate law: R is directly proportional to N2 की power 0 H2 power 0. Order 0. Zero order reaction. 2N2O5 in presence of heat gives 4NO2 plus O2. Order 1. Here are some other example of second order reaction. Unit of rate constant. Zero order reaction rate is directly proportional to reactant power 0. Here the unit is mole liter inverse second inverse. First order reaction the unit is second inverse. For second order reaction unit is mole per liter per second. For third order more mole square inverse liter square second inverse. In case of pressure, K is equal to 8 atmosphere atm raised to power 1 minus n second per second. Integrated zero order reaction. R is equal to negative d concentration of R by dt gives K into concentration of R raised to power 0. Here we can solve dt goes that side and then we take integration and solve this. From here we will find the value of I and put this value in equation number 1 for that, and we calculate K is equal to R naught concentration of R naught minus R concentration of R by T. From here we can find the value of T and T half. There, this is the graph for R and R concentration and T half and R concentration. Integrated first order reaction. In this case R is equal to negative dr by dt, and here K into concentration of R raised to power 1 and dt goes this side, and then we again take derivation or integration and then solve this. From here we will calculate the value of 5, that is negative log natural of R naught, and then put this value in equation 1, and from here kt is equal to 2 log natural R naught by R. We will put the value of log natural 2.303 log R naught by R, and this is the graph, and hence we solve for T half, and value of T half comes down to 0.693 by K. Radioactive disintegration. For first order reaction K is equal to 2.303 by T log N naught by N, and then we solve this N naught T half is equal to 0.693 by K. Average life is equal to 1 by K, and value comes 1.44 into T half. Here is a numerical we can solve by using the first order reaction. Molecularity of reaction: number of molecules that must collide to form product. Balanced chemical equation: 2N2O5 in presence of it gives 4NO2 plus O2 bimolecular. Reaction mechanism: the pathway through which R has been converted into a product. Slash step of the reaction. Rate determining step: 2N2O5 in presence of it gives 4NO2 plus O2. First step: N2O5 in presence of it gives NO2 plus NO3 intermediate, and in second step N2O5 plus NO3 gives 3NO2 plus O2 fast step. Graphical representation method is this is the representation of zero order, first order, second order and third order. Pseudo first order reaction: higher order reaction but due to the condition it becomes first order. Hydrolysis of ester and inversion of sucrose is example of pseudo first order reaction. Temperature coefficient is equal to rate constant of at T plus 10 degrees Celsius upon my rate constant at T degree. Collision theory: it depends on collision frequency and effective collision. Collision frequency is equal to number of collision taking place between R in 1 second. It depends on two factors: proper energy and proper orientation. Pseudo unimolecular reaction: hydrolysis of ethyl acetate CH3COO C2H5 plus H2O gives CH3COOH plus C2H5OH. Inversion of cane sugar: C12H22O11 plus H2O gives C6H12O6 plus C6H12O6. Glucose and fructose: first and second are bimolecular but are found to be of first order. Experimentally it was found that rate of reaction is directly proportional to concentration of CH3COO C2H5 only, and in second, rate of reaction is directly proportional to concentration of C12H22O11 only. This is because of the fact that water is present in such a large excess that its concentration remain almost constant during the reaction. Such reactions which aren't truly of first order but under certain conditions become first order are called pseudo unimolecular reaction. Kinetics of reaction. CH3COO C2H5 plus H2O gives CH3COOH plus C2H5OH. Here acetic acid is one of the products, the amount of which can be determined by titration against standard NaOH solution. Being an acid catalyzed reaction, the acid present originally as a catalyst but also reacts with the NaOH solution. Volume of NaOH solution used in the beginning at zero time is directly proportional to the amount of acid present only as catalyst is product at t is equal to 0. Reaction 1. Volume of NaOH solution used at any instant of time is directly proportional to amount of acid present as catalyst plus amount of CH3COH produced. Combining results 1 and 2, we find that amount of CH3COH produced at any instant of time is directly proportional to Vt minus V naught. Hence, X is directly proportional to Vt minus V naught. It is equation 4. Volume of NaOH solution used after the reaction has taken place for a long time, say 24 hours or so called infinite time, is directly proportional to amount of acid present as catalyst plus max amount of CH3COH produced. Combining results 4 and 5, we find that a maximum amount of CH3COOH produced is directly proportional to V infinity minus V naught, but a maximum amount of A is directly proportional to V infinity minus V naught. From 4 and 6 we have A minus X is directly proportional to V infinity minus V naught minus Vt minus V naught. A minus X is directly proportional to V infinity minus Vt. Now we know for first order, K is equal to 2.303 by T log upon A minus X is equal to 2.303 by T log V infinity minus V naught by V infinity minus Vt. Inversion of cane sugar, sucrose. The hydrolysis of sucrose is presence of mineral acid takes place according to the reaction. C12H22O11 plus H2O gives C6H12O6 plus C6H12O6 glucose plus fructose. Sucrose is dextrorotatory, whereas products of glucose and fructose are dextrorotatory and levorotatory respectively. Levorotation of fructose is more, being 90 minus 90 than the dextrorotation of glucose being plus 52.5 so that the mixture as a whole is levorotatory. On hydrolysis, the dextrorotatory sucrose gradually changes into the levorotatory mixture. It is for the reason that the reaction is called inversion of sucrose. Kinetics. The kinetics of the reaction is studied by nothing the angle of rotation but different intervals of time with the help of polarimeter. Paddling reading of polarimeter. Suppose reading of polarimeter at 0 time is equal to R naught, reading of polarimeter at time t is equal to RT, reading of polarimeter at infinity is equal to R infinity time. Reading at 0 time will be positive, reading would decrease with passage of time, pass through 0 and ultimately becomes negative. Angle of rotation at any instant of time, R naught minus RT is directly proportional to the amount of sucrose hydrolyzed. X directly proportional to R naught minus RT. Equation 1. Angle of rotation at infinity time, R naught minus R infinity is directly proportional to the initial concentration of sucrose. A directly proportional to R naught minus R infinity. Equation 2. From result 1 and 2 we have A minus X is directly proportional to R naught minus R infinity minus R naught minus RT. A minus X directly proportional to RT minus R infinity. We know that for first order reaction, K is equal to 2.303 by T log A minus X is equal to 2.303 by T log R naught minus R infinity upon RT minus R infinity from 2 and 3. Reactions of second order. A reaction is said to be of second order if the rate of reaction depends upon two concentration terms. Two A products A square, A plus B products rate is directly proportional to concentration of A and B both. So this is rate expression for second order reactions. Case 1, when the reactants are different, consider a second order reaction. A plus B gives B, where the initial concentration of A is mole per liter and that B is B mole per liter. Here comes A mole per liter. After time t, x mole per liter of A and x mole per liter of B react to form x mole per liter of the product. Thus, at time t, concentration of A is equal to A minus x mole per liter and concentration of B is equal to B minus x mole per liter. The differential rate expression for the second order reaction is R is equal to minus dA by dt is equal to minus dV by dt upon my dP by dt. K is equal to A concentration and B concentration. This can be written as R is equal to dx by dt is equal to K A minus x B minus x. Equation 1, separating the variables, we have dx by A minus x into B minus x is equal to K dt. It can be written as 1 by A minus B bracket closed 1 by B minus x minus 1 by A minus x dx is equal to K dt. Integrating, we get A minus B. If we take integration and then it comes, when we integrate, it comes down to A upon A minus B bracket log natural A minus x minus log natural B minus x is equal to Kt plus I. From log formula we can write in this method, and then where I is the constant of integration, we put t is equal to 0 and x is equal to 0, and then we get the value of I is equal to 1 by A minus B log natural A by B. Then we put the value of this into the equation 3. Value of I in equation 3, 1 by A minus B log natural A minus x upon B minus x is equal to Kt plus A minus B log natural A by B. We take this opposite side, Kt is equal to 1 by A minus B log natural A minus x on B minus x minus A by B log natural A by B. We take 1 by A minus B common, then this is formed and the final results come down to this. Equation 5, K is equal to 2.303 dA minus B log dA minus x AB minus x. When we put A is equal to C node and A minus x is equal to CT, B is equal to C node and B minus x is equal to CT, this comes down to this reaction. Note, if one of the reactants is present in excess, say B as in excess, B will large in comparison to A, so that A minus B is equal to B minus x. K is equal to 2.303 by minus bt log B A minus x upon B A B is equal to 2.303 by bt log A power inverse by A whole power inverse. And this case 2, when both the reactants are same, the second order reaction in the case can be represented at 2A gives P, and the rate of reaction is equal to R is equal to minus 1 by 2 dA by dt is equal to dP by dt is equal to Ka square. This can be written as R is equal to dx by dt is equal to K A whole power A minus x K whole power raised to 2, where A is equal to initial concentration of A and x is equal to concentration of product formed after time t. A minus x is equal to concentration of A remaining at time t. Separating the variables and integrating comes the result, integration dx by A minus x square is equal to K integration dt, and it comes A by A minus x is equal to AT plus C. We know that at time t is equal to 0 and x is equal to 0, A by A minus 0 is equal to K0 plus C. C is equal to 1 by A. Putting this value, okay, 1 by A minus x is equal to Kt plus 1 by A is equal to Kt is equal to A minus x minus A by 1 by A is equal to K is equal to 1 by T a minus x minus 1 by a. Well, here comes the result, k is equal to 1 by t x by a minus x. Characteristics graph, you can see here, this is the characteristics graph. And then comes third order reaction. A reaction is said to be third order if the rate of reaction depends upon the three concentration terms. Here three types of reactions are possible. All three are different, two are similar, and one is different, and all three are same. These are the examples. Rate expression is equal to 3a gives product t is equal to 0, a 0, t is equal to a minus x, x, where a is the initial concentration of a, x is the decrease in the concentration of a in time t, and a minus x is the concentration of a at time t. Now the differential rate equation is dx by dt is equal to ka minus x whole power 3, where k is rate constant for third order reaction. Equation 1 may be written as dx by a minus x whole power 3 is equal to k dt. Dx by dt is equal to ka minus x whole power 3 is equal to equation 1. And this here goes result 1 by 2a minus x whole square is equal to kt plus I. At t is equal to 0, x is equal to I is equal to 1 by 2a square. And then putting this value and solving further, the result comes k is equal to 1 by 2t x 2a minus x a square a minus x whole square, replacing a by c node and x by c node minus ct. Here comes result, k is equal to 1 by 2t 1 by c square t minus c square node. Characteristics of third order reaction. Unit of rate constant is equal to liter square mole inverse square second inverse. Half-life period. The time taken for half of the reaction to be completed. T half is equal to 3 by k c node square. Note, in general, T half is directly inversely proportional to a n minus 1. This was our chapter.